There's one basic thing or the foundation kind of thing for testing of hypothesis, which everyone should know, that is central limit theorem. Why I'm talking about Z distribution and then other distributions, this gives a hint to all the things. What that is uh, consider usually Z distribution or the Gaussian distribution is used when the given data is very large, like right? Binomial distribution as n tends to infinity goes to normal distribution. Was the discussion in the previous cases, right? So why am I using Z distribution or normal distribution for the population and all the things are discussed clearly in central limit theorem. What that says is consider the distribution of sample means. Consider the distribution of sample means mu x and standard deviation mu x bar, standard deviation x bar based on random samples of size n, random samples of size n drawn from an underlying population with mean mu and standard deviation sigma. Okay. Yeah, I can just write here as previously discussed. This is the population. And from this, I am drawing samples. Okay. So consider the distribution of sample means. Okay. Sample. These are all the samples. X1 bar is the mean of first sample. X2 bar is the mean of second sample. X3 bar is the mean of third sample. Now I'm considering mu x bar to be the mean of all the samples, guys. Try to understand this logic behind the theorem. Okay. Now, what the central limits theorem statements goes like are, if original population is not normally distributed, then the distribution of sample means the distribution of sample means is assumed to be approximately normally distributed. Okay, normally distributed, provided when this can happen is provided the sample size is large. Sample size is large. Sample size, I'm denoting it by small n, guys. Of course, population size capital N, small n1, n2 would be sample sizes. Okay. Yeah, that's what is the major assumption. I can just pictographically show the same concept. See here, what that's been given is x1 bar, x2 bar, x3 bar, x4 bar. These are all normally distributed. I don't know about whether the given population is a normal population or not, but the sample means are all normally distributed is the assumption, major assumption of what's that? Central limit theorem. First and Major assumption. Now, the mean of sample means mu x bar is denoted by mu. That's the second assumption. Similarly, the standard deviation of samples is assumed to be sigma by root n. Okay, these are the major assumptions of central limit theorem. What is it? If the original population is not normally distributed, then we assume that the distribution of sample means is normally distributed. Okay. Now, when do I see? There are different tests now. Let me give a gist of all the tests. There's a Z test. There's a T test. There's an F test. Right? Now, Z test is for Z test I will use when the sample size n is greater than 30, guys. When sample size n is less than 30, I'll go with T test. When do I use a F test is when I'm asked to find things in variance, draw conclusions in variances, then I'll go with F test because the F test formula is only ratio of variances, okay, of one sample with the other kind. Okay, so when do I use Z test? I'll be using Z test when the sample size is greater than 30. When the sample size is less than 30, I'll be using T test. F test I'll be using when I'm asked about things in variances. Of course, let me give the gist of chi-squared as well. I don't have neither means nor standard deviation and all those things. I'll be given some observed frequencies. I'll be given. I'll be calculating expected frequencies and the difference between chi-squared formula goes like OI minus EI whole squared kind. The difference between observed and expected frequencies only I'll consider and make conclusions. Okay. That I'll be using chi-squared I'll be using at that time. Yeah, I think I am clear. Now let me write the test statistics Z, T and all. Okay. Yeah. What's the test statistic for Z is given by x minus mu by sigma by root n. Okay, sometimes they'll take sigma as well. Okay. Yeah. T is also similar. Here n is greater than 30. T is also similar, guys. T distribution is also similar. Okay, T distribution formula also looks like that only. I'll just try it. I'm just looking into it just to avoid errors. T distribution is for small samples. T formula would be x bar minus mu by sigma only. It is x bar minus mu by sigma only. Yeah. X bar minus mu by, instead of sigma, I can write as well. Okay. Same thing, same formula. I will just cross check it so that I don't write errors. F, as I made a mention, it is S1 squared by S2 squared. Which variance is S1, which variance is S2, we'll talk about. As chi-squared also, I made a mention. Okay. Now, in Z, there are variety of things, guys. What that is in Z, normally it is this. Okay, if there are two samples, then I'll be having different formulae in Z. Okay, let me write all those formulae in Z so that you understand the gist of the things that we'll be learning in Z. Okay, if I have two samples, then Z statistic will be x1 bar minus x2 bar by under root of sigma squared by n1 plus sigma squared by n2. This is one formula. If sigma is not available, then it would be S1 squared by n1 plus S2 squared by n2. Of course, there are different versions of this formula. Again, I'll talk about those different versions also when needed. But as of now, If there are only two samples, no population means are there. If I'm being asked about two samples, I'll be taking like this. Z. Okay, there's another version. This is the first version, by the way. This is the second version. Coming to the third version. Instead of mean and all, for large samples, I'm being given some proportions. Proportions I'm being given of the sample and the population. Then the difference in sample and population proportions I'll be taking. Okay. So it would be under root of capital P by capital Q. Capital PQ by N. Okay. Yeah. Capital P plus capital Q is equal to 1. So if I know P, I can get Q. If I know Q, I can get P. That's one way. Difference in proportions also. Let me write, and with that I will end. I will end this video. There's one more formula on difference in proportions. Okay. If there are two proportions that's been given to me, I mean two samples that are being given to me, then what I will do? Z is equal to P1 minus P2 by under root of PQ, small p and small q only, 1 by N1 plus 1 by N2. This is how I will take. Okay. These are the four different versions of Z statistic. One is the two samples one, where I have mean and mean of the two samples. This is also two sample one, where I have instead of mean, I have proportions. Okay. Single sample one, I am having in proportions a Z formula. And then in means, I have one formula. T is anyways the same formula, but for N is equal to N less than 30. Okay. Yeah, I think I'm clear with this, right?